Stationary point, example 1. Find the coordinates of the stationary point of the curve y equals x cubed minus 6x squared minus 63x plus 21. A bit of introduction here. For a quadratic curve where y equals ax squared plus bx plus c, when you sketch that curve, it's more like that. That's for positive quadratic, where a is positive. And you can see that's a quadratic there. This is y, and that's x. For a cubic, where y equals ax cubed plus bx squared plus cx plus d, because it's cubic, you'll start from a positive cubic. We'll start from the third quadrant here, and across the x-axis 3 times. Again, that's y, x. And for a quartic, where you have y equals ax to power 4 plus bx cubed plus cx squared plus dx plus e. When you sketch that curve, you expect it to, for a positive quartic graph, you expect the graph to cross the x-axis 4 times. So a quadratic crosses the x-axis twice, and it's got one turning point or stationary value here. So that's the stationary point here, 1. A cubic has 2 stationary points, and a quartic has 3 stationary points. So it's always good to remember that. So this is quadratic, this is cubic, and this is quartic. So this is y-axis, that's the x-axis. At the turning point here, that's a turning point, turning point, turning point, 3 turning point, 2 turning point, 1 turning point. At the turning point, which is stationary, the y, the x, equal to 0. The question says, find the coordinates of the stationary points of the curve y equals x cubed minus 6x squared minus 63x plus 21. So this is cubic, this one here. So we're expecting 2 turning points, hence the coordinates and the points. If you differentiate quartic, you get cubic. If you differentiate cubic, you get quadratic. Now, let's have a go with this question. Y equals x cubed minus 6x squared minus 63x plus 21. The y, the x, will be equal to differentiate, you must have a function y equals x to the power of n. Then the y, the x, will be equal to n x to the power n minus 1 times the x, because this is x here. The x cancel, that's just 1. So you just get n x to the power n minus 1. And that's what we're using, but we got 4 terms here. 1, 2, 3, 4. So we have to differentiate term by term. In this case, n is 3, so that'll be 3 times 1, x, 3 minus 1 to the power 2, minus 2 times 6, 12, x, 2 minus 1, x to the power 1, minus, that's the power of 1 times 63, so that'll be 63, x 1 minus 1 to the power of 0. The constant also has a variable. It's x to the power of 0. Every constant has its own variable with a power of 0. 0 times 21, that will be plus 0. So the dy dx for this function will be equal to 3x squared minus 12x minus 63, because x to the power of 0 equals 1. 1 times minus 63 is minus 63. So now, at the turning point, at the stationary point, which is the turning point in this case, so that's a turning point, that's a turning point, that's a turning point, the y dx equals to 0. 3x squared minus 12x minus 63 equal to 0. We need to divide both sides by 3. That's a common factor here. X squared minus 4x minus 21 equals to 0. So that reminds me of a quadratic where y equal to 0. In this case, a equals 1. There's 1 here. B equals minus 4. And C equals minus 21. I need to find AC. 1 times minus 21 is minus 21. I need two numbers I could multiply together, and they will give me minus 21. And when I add them together, I get minus 4. So that will be the product will be minus 21 of those two numbers, and their sum will be minus 4. In this case, 3 and minus 7 should give me minus 4. All I need to do is put x here, x there, and x there. And then I can replace minus 4x here with 3x minus 7. So I get, from that expression here, I get x squared plus 3x, that's plus 3x, minus 7x. So now that equals minus 4x. Minus 21 equal to 0. Now with this equation, x is a common factor and minus 7 is a common factor. If I take x out, I will get x into bracket x plus 3 minus 7 out because there's a minus here, so I'm taking minus, and 7 is common, so it's minus 7, open bracket. If I take minus out from here, the sign next to that will change. X plus 3 equal to 0. Now I can see a common factor here, x plus 3, and I'm left with x minus 7. Therefore, x minus 7 times x plus 3 are the factors, and that equal to 0. Then I need to set these to 0, these two factors to 0. If I set that to 0 and set that to 0, x minus 7 equal to 0. X equals to 7. X plus 3 equal to 0. X equals to minus 3. Now I've got the two values here. So one of them is 7. If you think about it, this is the curve. That's 7 there. And minus 3 will be here. Now I need to find the value of y, this value of y here. To find the value of y, I need to plug those numbers here back into that equation, into this equation. So when x equals minus 3, y will be equal to, if you plug these values in for y, when x is minus 3, you will get 129. And when x equals to 7, y will be minus 371. So the coordinates are minus 3, 129, and 7 minus 371. Those are the coordinates. To find the value of y, all you need to do is to say x equals to minus 3, and then you have y equal to minus 3 cubed minus 6 into bracket minus 3 squared minus 63 into bracket minus 3 plus 21. And then you do the same with the 7, and then you get those values. You have to plug those values into your calculator correctly, and then you can get those values.